So the next question is, we have to write the chemical equations for the following conversions. We have to convert nitrobenzene to benzoic acid and write all the steps involved. So first, this is nitrobenzene. We will react it with, so we know this will reduce it to this. Now we will do the Clement reaction at 0 degrees Celsius. We will get and finally we will react it with CuCN to get this. Now we will react it with high acidic oxidizing agent, and then we will get benzoic acid. Now we will go to the second part of the second conversion. The second is benzyl chloride. Has to be converted to 2-phenyl ethanamine. So benzyl chloride this is benzyl chloride. We will react it with KCN. So the CN group, CN negative group, will replace the Cl negative group. We will get this. Now we will perform this reaction in presence of LaAlH4, or we can also use hydrogen in presence of nickel, reduce it to this. So we are reducing the CN group here to CH2NH2, and we finally get 2-phenyl ethanamine. The third conversion that we have to do is aniline to benzyl alcohol. So we will take aniline and do this conversion. In 0 degrees Celsius we have to do this reaction, we already know. So we will get the same product as we got in the first conversion. Now we will react with H3PO2 and H2. This will eliminate this group, and we finally get benzene. Now what we will do? We will react with CH3Cl in presence of anhydrous AlCl3. This will result in addition of CH3 group on the top. So we will get, now we have to react it with chlorine in presence of sunlight. it will form this via the free radical mechanism we already know, and finally we have to treat it with KOH, a very strong base in aqueous solution, and it will result in elimination of chlorine group and we will get an alcohol. So we have finally converted aniline to benzyl alcohol. So the next question starts. So the next question is, what are the following substances, and give example of each of them. So the first part is tranquilizers. So tranquilizers are chemical foods chemical compounds, we must say, they are used in the treatment of stress and mild or even severe mental diseases. So they are used in stress or mental diseases. So example of it is Equinol, Equinil, Veronal, or even Meprobamate. So these are the examples of it. So tranquilizers are chemical compounds that are used in stress or in the treatment of stress or mental diseases. So the second part is food preservatives. So what are food preservatives? These are the compounds that prevent spoilage of food. Basically, the spoilage of food is due to microbial growth. So these compounds, food preservatives, they reduce the microbial growth and therefore help in preventing spoilage of food. Examples are vinegar. We have all seen that vinegar is used in our common kitchen households, and sodium benzoate. The next part is synthetic detergent. So what are synthetic detergents? They are the cleaning agents which have all the properties of soap, but which actually do not contain any soap compound in it. Most common example is sodium lauryl sulfate. Start. So the next question is, what type of battery is a lead storage battery? Write anode and cathode reactions and the overall reaction occurring in a lead storage battery when current is drawn from it. So the first part, lead storage battery is actually a secondary cell. Now we'll write the anode, cathode and overall cell reaction. The anode reaction is lead Pb plus sulfate gives lead sulfate in solid form, releasing 2 electrons. The cathode part of the reaction is the reaction that is occurring at the cathode of a lead storage battery. Lead oxide plus hydrogen ions plus sulfate with consuming 2 electrons gives lead sulfate plus water. So as we know, in a lead storage battery there is hydrogen sulfate present in large amount in liquid aqueous form. So sulfate is used at anode with lead to form lead sulfate, and as cathode the solid lead oxide is reacted with sulfate ions to form lead sulfate in water. So the overall reaction is overall reaction of the cell is lead plus lead oxide plus sulfate. We will add the 2 reactions and get the overall reaction plus so this is the overall reaction that is occurring. We have found the overall reaction by joining the anode and cathode reaction. So the next part of the question is, in a button cell, the small cell which we have all seen in watches, the following reaction takes place. Zinc plus Ag2O plus H2O gives Zn2 plus Ag plus OH negative. So we have to determine the E0 and delta G0 values for this reaction, and we are given that E0 for Ag positive to Ag reduction potential is 0.80 and E0 for Zn2 plus to Zn is minus 0.76 volt. So we all know that E0 of cell equals to E0 of cathode minus E0 of anode. As we see, the cathode is where Ag plus is going to Ag, and the anode is where Zn is going to Zn2 plus. So E0 cathode is 0.80 minus 0.76 the potential for the anode, and it comes out to be plus 1.56 volt. So E0 value for the cell is plus 1.56 volt. Now we will find out the value of delta G0. So delta G0 equals to minus NF E0 cell. So this is the formula. Delta G0 equals to minus NF E0. So here we see that there is a exchange of 2 electrons. Zn is going to Zn2 plus, which means it is losing 2 electrons, and 2 atoms of Ag positive are going to Ag, which are in total taking 2 electrons. So N here is 2, so it is minus 2 into the value of F is 96500 coulomb mole inverse, and we have found out the E0 of the cell, that is 1.56 volt. So it comes out to be minus 301,080 joule mole inverse. Or we can also write it in kilojoule, that is minus 301.08 kilojoule mole inverse. So delta G naught of this reaction is minus 301.08 kilojoule per mole, and del E naught of the cell is plus 1.56 volt.